Hello, my name is Mohammed Zahid. Hello, my name is Mohammed Zahid. My topic is about history and evolution of virtualization technology. The history of virtualization technology was extended back in 1960s. Over the year, it has been significant change due to development in software and hardware, as well as increasing needs of computer network. The mainframe of virtualization has introduced in 1960s. The introduction of mainframe computer gives rise to idea of the virtualization. Virtual machine was firstly introduced by IBM with CP40 and CP67 operating system, which allowed several operating systems instances to run simultaneously on a single frame. And then next, in between 1980s to 1990, early computer virtualization as personal computer developed in the year between 1980s and 1990s. Virtualization technology were less common because of their low processing capacity and predominance of single user operating system like Windows and Mac DOS virtualization. However, it was introduced in to x86 architecture PC by software such as VMware Workstation, which is launched in 1999, which allowed several virtual machines to operate on a single physical system. Then in 2000s, server virtualization. VMware EXA server and software virtual server were the main players in early 2000 server virtualization technology by combining several physical servers into virtual machines. And then open source virtualization. Open source virtualization technologies like Zen and KVM gain popularity in addition to commercial products like VMware, originally created at the University of Cambridge. Zen provided para virtualization, however, it required changes to the guest operating system to function as it best could. Complete virtualization was achieved with kernel-based virtual machine, which was built into Linux kernel and did not require changes to the guest operating system. Then in 2010s, the cloud computing. Virtualization was essential to growth of technology. Virtualization was a key component used by infrastructure as a service, which is called as providers such as AWS, Amazon Web Service, Google Cloud Platform, GCP, Microsoft Azure, consume to provide consumer with flexible, scalable computing resources around the globe. These cloud services were made possible by technologies like Microsoft Hyper-V, Amazon EC2, which allowed quick development of virtualized resources. Then from 2010 to 2000 present, containerization. From 2010 to present, containerization has been popular and low cost substitute for traditional virtualization, which require running whole virtual machine with separate operating system without complexity of running distinct OS instance for every application. Technologies like Docker and Kubernetes enable apps to be packed with their dependencies into container, then can operate on any system that support containerization. Then and then next, edge computing and IoT present future. Virtualization is still developing to satisfy the needs of cutting edge technology. Resource management and utilization is distributed computing settings are made possible using virtualization technologies for edge devices. Then my next topic is about hypervisor. Hypervisor is now we can now we can also called as virtual machine monitor. It is a software layer which manages all interaction between virtual machine and the physical hardware resources. The physical resources like CPU, memory, storage are managed and assigned to virtual machine with the help of hypervisors. Hypervisor plays a crucial role in virtualization, allowing multiple virtual machine into single physical server. The hypervisor can run directly on hardware or on application on operating system. There are two types of hypervisors: type 1 hypervisor and type 2 hypervisor. Type 1 hypervisor, which is run directly on a hardware. It manages the guest operating system and provides them direct access to underlying hardware resources. Type 1 hypervisor offers better performance. The example of type 1 hypervisor are Zen, Microsoft Hyper-V, VMware EXI. We can see in the image that here hypervisor is operated directly on the hardware, and then above the hypervisor guest OS. Then next is type 2 hypervisor. Type 2 hypervisor, it runs on the top of the OS, where we can see in the figure, which is running on the operating above the on the operating system, and then guest OS. Uh, it used it for desktop development and testing rather than production environment. Oracle VirtualBox and VMware Workstation are the example of Type 2 hypervisor. Then next, virtual hardware. The term virtual hardware describes emulated hardware element that hypervisor provides to the computers. Virtual CPUs, virtual RAMs, disk drives, and network ports and other peripherals are included in this. The guest operating system running on the virtual machine are presented with virtualized copies of real hardware via hypervisor. And then guest operating system. Operating system that are installed within virtual machine are known as guest operating system. They are not aware that they are working operating on virtualized hardware instead of hardware when they interact with virtual hardware that the hypervisor has given. Ma, the next part will be explained by the Srimuki, my friend.
Okay, hi, good evening all. This is Srimuki. I'm here to say about methods and tools for VM cloning and copying. Firstly, hypervisor tools like VMware, vCenter Server, and Microsoft Hyper-V Manager offer user-friendly interfaces for customizing VM cloning process. If we prefer automation, then CLI command line interfaces such as VM tools and PowerShell allow scripting and streamlining tasks. For comprehensive features like cloning, backup, and replication, third party solutions like VM backup and replications are available. Snapshot based cloning effectively utilizes hypervisor snapshots, while storage based cloning leverages array technologies to optimize performance. If you are looking for simplicity in creating the and deploying VM disk images, tools like Clonezilla are handy. Ultimately, the choice of method or tool depends on factors like ease of use, scalability, performance, and integration needs to ensure smooth VM management. Then, while coming to the differences between cloning and copying, the major differences are when we clone a VM, we are essentially creating an identical twin of the original VM. This clone operates independently from the original, meaning that it changes made to one instance won't affect the other. Cloning is often used when you need multiple identical instances of a VM quickly, such as in testing environments like that. It creates a new set of VM files with unique identifiers, essentially building a separate entity from the original VM. On the other hand, copying a VM involves duplicating its files, including configuration files and virtual hard disks, but it doesn't necessarily create an independent instances like cloning does. Changes made to the original VM after copying won't affect the copy. So they are still closely tied together in terms of file structure. Copying is commonly used for creating backups and transferring VMs between hosts or storing templates for deployment. And when we talk about tools, there are many tools like VMware, vCenter Server, Microsoft Hyper-V Manager, Oracle VM, VirtualBox, VM Backup and Replication, and many other tools, which helps in authorizing a centralized hub for managing numerous VMs, hosts, and clusters. This is about methods and tools for VM cloning and copying, and the next part will be explained by my friend Abdul. And over to you, Abdul. Thank you.
Hello, this is Abdul Rahman Muhammad. I'm here to present about the technical challenges and solutions which will be occurring at the time of cloning. During the cloning process of a computer system, several common issues can arise due to differences in hardware, settings, or unique identifiers. Firstly, universally unique identifier, simply known as UUID. Conflicts occur when cloned components have the same UUID as the source system, potentially leading to device detection issues and data corruption. To mitigate this, tools or scripts like UUIDGEN in Linux or specialized software in Windows can be used to generate new UUIDs for clone components. Similarly, SID duplication in Windows system can cause authentication problems and security policy issues. Utilizing tools like sysprep during cloning helps generalize the system and generate a new SID addressing these concerns. In addition to this, network configuration conflicts such as duplicate IP or MAC addresses can disturb network connectivity and services post cloning. Manual updates to network configurations or automation tools are essential to ensure unique addresses. Additionally, activation and licensing issues may arise, restricting functionality in software or operating systems. Proper licensing compliance, volume licensing solutions, and activation guidelines are crucial to avoid such restrictions. Moreover, Incorrect, incorrect partition or disalignment during cloning can degrade performance and efficiency. By balancing the use of disk management tools or alignment utilities for optimization. Finally, retaining specific configuration from the source system can lead to compatibility issues and operation inefficiency in cloned systems. Adjustment to system configuration post-cloning, including hostname, domain settings, and system roles, help align with the requirements of the new environment, mitigating these challenges. When coming to strategies, prevent UUID conflicts, followed by handle SID duplication, avoid hostname or IP conflicts, resolve driver or hardware issues, manage licensing challenges, ensure data integrity are some of the ways to minimize risk during cloning processes and facilitate the smooth deployment of cloned systems, reducing operational disruption and downtime. This is regarding technical issues and solution. Thank you. Then the other part will be continued by my friend Lehini.
Hello everyone, I'm Lihini Herat. In this part, I'll discuss the security concerns of virtual machine cloning. Uh, because although the virtual machine cloning is so important, that can include several vulnerabilities if VM cloning is not managed properly. First security concern is template tampering. One major one major concern is the possibility of template tampering. If a virtual machine template is configured or compromised uh, incorrectly, uh, all cloned instances will inherit these vulnerabilities so that attackers could exploit this to compromise other cloned VMs by gaining access to these templates and injecting malicious codes. The second one is snapshot vulnerabilities. Snapshots, while useful for backup or recovery, this can become a security risk if not this is handled carefully. Cloned snapshots contain sensitive data or vulnerabilities could be accessed by unauthorized users. This can lead to data breaches or system compromise. And the other one is data leakage. Cloning VMs without proper data sanitization can lead to data leakage. Because clone instances may contain residual data from the original VM, including passwords or encrypted keys, which could be accessed by the other parties. The fourth one is credential exposure. Cloning VMs without caution can expose sensitive information such as usernames, passwords. If the original VM has hard-coded those credentials, details, uh, so that these details get copied over to clones, increasing the risk of uh, attacks. The other one is network misconfiguration. Clone VMs may inherit network settings from the original VM, including IP addresses, firewall rules. Failure to update or manage these settings correctly can lead to network conflicts or unauthorized access. Uh, And the license compliance is also very important because if we don't update our licenses or security licenses, the cloning virtual machine without adhering these license requirement can lead to serious consequences, including license violation or breaches of software license agreements. Uh, in the next part, I'm going to explain about the strategies to mitigate these challenges. First one is it is very important to start VM cloning with a secure template. The first step is to use a securely configured based image as the foundation for creating VM template. This involves applying security patches, removing unnecessary software, and configuring security settings according to the industry best practices. By starting with a secure template, we can establish a strong security foundation for all the cloned VMs. This minimizes vulnerabilities across the environment. And the second one is sanitize the templates. Before duplicating a VM template, it's crucial for thoroughly clean it to remove any secure sensitive information or configurations. Utilize specialized tools uh, can uh, can be useful for this process. And the third one is encrypt sensitive data uh, to ensure that uh, any sensitive data in the VM template is encrypted during the transit, and the rest is important. We can utilize the encryption tools provided by virtualization platform to maintain the confidentiality and integrity of the data. And the fourth one is the we can use automation and templates. Uh, Take advantage of automation solution and VM templates to streamline the replication process. By using these templates, we can significantly reduce manual errors and ensure consistency across replicated instances. Automation makes copying VMs faster and more efficient and ensuring uniformity and reliability. And the other one is implement least privilege access. It's very important because limiting access to VM templates and cloning procedure to unauthorized people. We can utilize role-based access controls to restrict this access according to the job duties. Minimize the risk of unauthorized changes of cloning activities. The seventh one is we have to keep an eye on VM cloning activities. Set up systems to monitor VM cloning activities using auditing and monitoring tools. Keep an eye out for unauthorized cloning efforts or unusual activities that could indicate security breach. Early detection of these activities can help prevent security incidents and minimize their impact. And the eighth one is secure configuration, network configuration. Uh, we should ensure that cloned VMs have appropriate network configuration, include unique IP addresses and firewall rules. To avoid IP conflicts and minimize this risk. And the last one is limit the snapshot usage. Uh, Use snapshots sparingly and ensure that are properly managed. Regularly review and delete unnecessary snapshots to reduce the attack surface and minimize the risk of snapshot related vulnerabilities. These are some concerns about and the method to reduce the security concerns regarding network VM cloning. I'll hand over Naveen to continue the rest. Thank you so much.
Good evening, all. My name is Navin Kumar. My topic is about case studies and real world application. Virtual machine cloning is nothing but process of duplicating an existing virtual machine to create an identical copies. It is useful in variety of application across different industries. Below are some of the use cases and practical applications. The first one is in environments for testing and development. Software developers sometimes need to test updates, so that they use cloning to quickly create testing environments. This helps them to save time and cost compared to manually building each environment. And the second one is about high availability and load balancing. um, it's nothing but it ensures that uh, there is no traffic across multiple instances of web servers, And also some companies can quickly expand their infrastructure by duplicating machines so that there is no interruption when the demand increases. And the third one is about continuity of operations and disaster recovery. Disaster recovery plans simply rely on virtual machine cloning because they duplicate entire IT infrastructure in case there is any system failure or natural disaster. And also companies create virtual machines, though they place them on site. If there is any demand, they simply take the existing machines. And the fourth one is about infrastructure for virtual desktops. It's nothing but it creates virtual desktop infrastructure which provides user with remote desktop environments. This approach also saves some time and also eliminating the need to set up individual desktop environment from for the user from scratch. And the fifth one is about software quality assurance and testing. QA teams sometimes create virtual machine image with necessary tools and configurations. Testers then clone this image to run test in isolated context without altering the original configuration. And the second part is about companies use virtual machine duplication to improve operational efficiency in several ways. The first one is about rapid deployment. Rapid deployment is nothing but with the help of virtual machine cloning, no need of manual setup. So companies easily launch additional instances which will reduce deployment time from days to minutes. And the second one is about resource optimization. Companies Organizations can save resources by cloning virtual machines instead of building them anew. And the third one is about scalability. Scalability is nothing but it makes easier for companies to scale up or down when they need it, which also increases quickly deploying resources to meet challenging demands. And the final one is about cost savings. Cost saving is nothing but with the help of virtual machine cloning, they can save money by reducing the cost for maintaining and managing infrastructure. Um, these are the things which are useful with the help of the virtual machine cloning. And the next part practical demonstration will be explained by Vinay.
Yeah, thank you, Naveen. Myself, Vinay Kumar. Now we'll be discussing about the practical demonstration of the cloning. Till now, we have seen whatever the theoretical aspects of cloning or copying a virtual machine. Now we'll see the practical implementation. This part was done by me along with Adarsh and Sushma. So now we'll see the step-by-step procedure of how we perform the cloning. Before performing the VM cloning, we need to create a VM first, and then we need to clone that particular VM. Here in our case, we have used the Oracle VirtualBox as our virtualization platform to performing the cloning. So we'll see the step-by-step procedure, how we created a virtual machine, and then we can see how we perform the cloning of the same. So in the first step, here we can see we are creating the new virtual machine with the name like we have given the virtual machine name, and here we are selecting the ISO image. Here we are selecting the ISO image as a Windows 10 file. So we are going to install Windows 10 operating system on this particular virtual machine. So once it is done, we are clicking on the next. So we'll be proceeding to the next step. Uh, Here in this step, we need to create the username and password for that particular virtual machine. Like whenever we are using to login, we need to enter these credentials to log into that particular virtual machine. Once we are done with setting up the username and password, we are proceeding with the next step. Here in the next step, we can see like we need to configure the machine memory and the processor. So here we are configuring the memory as 4096 MB and also the processor as single processor. So once we are done with creating the hardware, we'll be proceeding with the virtual hard disk. So here For this particular VM, we are creating the hard disk with the size of 50 GB. So here we can see we have mentioned the hard disk size as 50 GB and we are proceeding with the next. Okay, once we are done with all the configuration, we need to re-verify the configurations of the particular virtual machine like memory and hard disk size. Then we'll be clicking on the finish. Once we click on the finish, the VM will be started powering on. From this part, others will continue.
Hi everyone, this is Adarsh. Now I am going to explain. Uh, so in this step, we need to power off the VM first, and then, uh, sorry, once again, here the Windows is installing. It will take time to install, and after that, uh, we need to log in and give our password, which we have given in the first step, and then we can see the Windows is installed perfectly. So to clone the virtual machine, we have to power off this uh, original one, and then we can start our VM cloning process. This part will explain by my friend Shushma.
Hi, myself Sushma. I'm going to talk about the VM cloning. After power offing the virtual machine, the first step is the open the virtual box and we have to select the virtual machine that we want to clone from the list of VMs. After that, once we have chosen the clone option from the above screenshot, we need to enter the clone virtual machine name as like group B clown because we are group B, so we have gave the name as group B. After that, we have chosen the clown type as full clown to create the exact copy of the virtual machine. As we shown in the screenshot below, a clowned virtual machine has been created once the clowning procedure is completed. By selecting the start icon, we can start the clown virtual machine. Once the clowning process is completed, we have seen the recorded practical demonstration of the virtual clowning process. Here is the link for the same process. Here is the YouTube video where we had done the process. Thank you.